So for the second example here, we have a little bit of a different situation here. So the one thing that you should note here is the conclusion. So you might look at this conclusion and think, okay, well, how in the world are we going to get this? Because there's no instance in here where there's like a conjunction of B and C or the negation of that conjunction. And this is something that the selection that I had you guys read brings up, and it's worth mentioning now, is that you can use the rules of replacement to sort of deconstruct the conclusion in order to see exactly what you're going to really need to get out of the premises in order to reach this. So sort of off to the side, one thing that you can do, if it's not like a single letter, or if it's not something that's like obviously in the premises, is you can use the rules of replacement to see kind of what the equivalent of this conclusion would be. So generally speaking, when you're dealing with something like a conjunction here, and you have this tilde out in the front, immediately a rule that should come into mind in terms of rules of replacement should be the De Morgan's rule, okay? So one thing that you know with De Morgan's, as we said earlier, is that with De Morgan's you switch in this case, the conjunction to a disjunction, and you take out tildes where they had been and put in tildes where they had not previously been. So if we reverse engineered this conclusion, we would see then that we would take out that tilde out front, but we would put it in front of B and C. So we'd have not B and not C. And we know with De Morgan's that the ampersand would then convert to a wedge. So we can see here that this is another way of looking at the conclusion. And perhaps along the way here we can find a way, because we have a not B here, and we have a not C here, we can find a way in which we can disjoin these two letters here. So I'll write this out to the side so we have a little space. So we're kind of looking for something that looks like this, or we're looking for this. So let's go ahead and show how this would be done. So looking at our example here, one thing that kind of, when you're looking at these proofs and like trying to figure out where to begin, if you have a case again where you have a line like number 3, where it's a disjunction or a conjunction, and you have all these tildes in place, it's kind of a hint to you that this could be converted into, using the rule of De Morgan's, into, in this case, a disjunctive statement. So let's just as a sort of start here, again, it's always like, with all these proofs, you're sort of like trying to untie a knot, so you're trying to find that string that you need to pull in order to make it all fall apart. So let's go ahead and on line 3 use the rule of De Morgan's. So when we do that, we take out all of these tildes. So all the tildes go away, and we change the ampersand to a wedge, and there we have E or U. Okay. So as we can kind of see here, we have a U here, and we have a U on line 2. And again, we're really trying to get that not C and that not B out of 1 and 2 here in order for along the way we can conjoin them. So if we wanted to do anything with this, if we sort of looked at this, well, if you look at this on line 2 and 4, if you could do hypothetical syllogism, which again, hypothetical syllogism involves 2 conditional statements, if you could do that, you could at least get rid of these U's and be down to an E horseshoe not C. Okay? So let's go ahead and do that here. So on line 4, and we're trying to get this wedge to a horseshoe. And what rule can we use to do that? Well, the rule of implication, to look back at your rules here. So if we do that, then we get not E, because again, with implication, whether you're starting with a disjunct or a conditional, the opposite's going to negate it. So in this case, here we have, in this case, not E, and then U here, right? So we're done with this line 4. Okay, so now we can now do our hypothetical syllogism. So on 6, using lines 2 and 5, and using the rule of implication of hypothetical syllogism, we can see here the U's drop out, and we're left with not E, horseshoe, not C. Okay. Now Now we're left with only lines 1 and 6. So let's look at this here. So we have a not E and we have an E, and they're both to the left of the horseshoe. Well, if we could get them to be the same value and on the opposite sides of the horseshoe, then we could once again use hypothetical syllogism. And we specifically want to use hypothetical syllogism so that the B in this case, with the not B will be over, or the B will be to the left of the ampersand, or excuse me, the left of the horseshoe, I should say. Because again, to look back over here in terms of our reverse engineering, now it's looking more and more like we're going to end up with a kind of conditional statement. Well, if we look at what we got so far here with the not B or the not C, well, if we're trying to find a conditional, we can use implication here to reverse engineer that and see that if we do that, we'll have not B, not B, horseshoe, not C. And if we do double negation on that, we'll have B, horseshoe, not C. So that's kind of what we want. This is our goal now. Again, using kind of the conversion out to the side, we can do this. So, but first things first, let's try to get the E's the same value and on opposite sides of the horseshoe. And we want B to the left of the horseshoe, so the rule that can help us on that will be transposition. And the rule we should use it on, or the line we should use it on, is line 1, because the B is to the right here and we want it to be to the left. So on line 1, using the rule of transposition, we will switch it. So again, we switch it and negate it. So when you switch the not B around, it just becomes not B, horseshoe, not E. So there we go. So depending on what you want to do, if you want to get rid of this double negation first, we can get rid of that. So now it's B, horseshoe, not E. So by the way, let's get rid of these real quick here. Okay. And so that will be on line 7, the rule of double negation. Okay. And now we have the not E's on the opposite sides of the horseshoe. So using lines 6 and 8 and hypothetical syllogism, we can therefore, on line 9, derive B, horseshoe, not C. And we're not quite done yet. Let's see how much room we have. Let's go ahead and go over here. Erase this. Give ourselves some room. And so what we can do here is, so we've used this line and this line. So again, we're trying to make this into an ampersand. Well, before we can get this into an ampersand, we have to get it, you can't go from a horseshoe to ampersand directly. You have to go and convert it to a wedge first. So on line 10, using line 9 and the rule of implication, because the rule of implication converts horseshoes to ampersands, or horseshoes to disjuncts, I'm sorry. Using that, we know that we can get, then in this case, not B or not C. There we go, we use that. And we're almost there. Now we need to convert it into ampersand, and so we will do that. We'll have our B, our ampersand here, and then our B and our C, using line 10 and the rule of De Morgan's here. And the last thing that we have to do is we take out our our tildes where they were and put them in where they weren't before. So it wasn't, the tilde was not in front of the whole entire conjunct before. And then there we have it. We have proven the conclusion of not both B and C.